Hello everyone, welcome back to the ArgoCD series. Today's session is going to be a completely hands-on demo. In this video, we will learn how to create an application in ArgoCD and deploy a Spring Boot microservice into our Kubernetes cluster using a customized-based manifest structure. Well, using customized-based manifest structure is one of the most common approaches used in the enterprise environments. For this demo, let's consider our Kubernetes cluster as a SIT environment where ArgoCD has already been installed and configured. Let's first understand how to create an application in ArgoCD. Well, there are two ways to create an application in ArgoCD. The first one is manually through the ArgoCD Web UI, and the second is by using a Kubernetes manifest of kind application. Today we will focus on the manual approach and perform an end-to-end deployment using the ArgoCD UI. In the next session, we will learn how to create the same ArgoCD application declaratively using an YAML manifest. So let's get started. First, open the ArgoCD Web UI. This is my ArgoCD instance and I have already logged in as the admin user. To create an application manually, you will notice a plus new app button on the application page. But before we create an application, there are two important prerequisites that we need to understand. First, configure the Git repository. Remember, ArgoCD continuously pulls the desired state from Git. So before it can deploy anything, it needs access to the Git repository that contains our Kubernetes manifest. Well, if your repository is private, GitHub requires authentication before ArgoCD can access it. So instead of providing credentials every time, ArgoCD allows us to register the repository once. After that, any application using the same repository automatically reuses the stored credentials. Let's see how to do that. From the left navigation pane, go to Settings and then select Repositories. From here, click Connect Repo and choose the connection method as HTTP or HTTPS. For the type, Git is already selected and keep it as it is. Give the repository a meaningful name. In my case, I will use SEH students. For the project, I will use SEH, since that's the ArgoCD project I will be using. Next, provide the repository URL. From my repository, I will copy the URL and paste it here. Next, provide your GitHub username. Finally, under the password field, do not enter your GitHub account password. Instead, provide a GitHub Personal Access Token (PAT) with the required permission to access the repository. So I am providing my personal access token here in the password field. Once you have entered all the details, click on Connect. So if everything is configured correctly, the connection status will change to successful. Perfect. Our GitHub repository is now securely registered with ArgoCD. Well, the second prerequisite is to configure an ArgoCD project. Now you might be wondering, why do we need a project? Well, an ArgoCD project is simply a logical boundary that groups related applications together. It also helps us control which repositories, which Kubernetes clusters, and which namespaces those applications are allowed to deploy to. This makes application management much more secure and organized, especially in the enterprise environments. Now let's create one. Well, go back to Settings and then select Projects from here. Click on this plus New Project. This page will open. So first provide the project name. I will provide it SEH. One important thing to remember is that project name must be in the lowercase and should consist only the lowercase alphanumeric characters. Next, provide a meaningful description. For example, I will provide this one. Now click on Create. Once the project is created, you will be taken to the project summary page where you can see all its details. Now we need to configure a few important settings. The first one is source repositories. So from here, click on Edit, click on Add Source and simply specify star here and save. So this tells ArgoCD that application in this project are allowed to use any Git repository. But in production environments, it's recommended to specify only the approved Git repositories instead of using star. Next, let's configure the destinations. From here, click on Edit, click on Add Destination. So here also provide server star, name as star or namespace also star, click on save. So this means applications in this project can be deployed to any registered Kubernetes cluster and any namespace. Again, in enterprise environment, you would manually restrict this to specify clusters and namespaces. Next, we have cluster resource. And from here, edit cluster resource allow list and namespace resource allow list. For that, click on edit. Under cluster resource allow list, add resource. For this demo, I will use star for all the fields. The same way for namespace resource allow list, click on add resource, use star for all the fields and click on save. For this demo, we will simply allow all resources by selecting group as star and kind as star. That's it. Our ArgoCD project is now configured. We are finally ready to create our first ArgoCD application. So let's go back to the applications from the left navigation pane and click on this new app button. This opens the create application page. Under the general section, we need to provide a few basic details. The first field is application name, which is mandatory. I will give the application name as SEH students. Next, the project field. From the drop down list, select the SEH project that we created just a few minutes ago. The next important field is sync policy. The sync policy controls how ArgoCD synchronizes the desired state stored in the Git and the actual state running inside the Kubernetes cluster. Here we have two options. One is manual, another one is automatic. Let's understand both of them. If you choose manual, ArgoCD will detect that changes are available in Git, but it will not deploy them automatically. A user must manually click on the sync button from the ArgoCD UI or trigger a sync using the ArgoCD CLI or API. On the other hand, if you choose automatic, ArgoCD continuously watches the Git repository, and whenever it detects a new commit or configuration change, it automatically synchronizes those changes to the Kubernetes cluster without any manual intervention. So when we click automatic, we get three additional options. The first one is enable auto sync. If this option is enabled, ArgoCD will automatically synchronize the application whenever it detects changes in the Git repository. The second option is Prune resources. Prune controls whether ArgoCD should delete Kubernetes resources that are no longer defined in the Git repository. For example, suppose your Git repository originally contains a deployment, a service, and a config map. Later, someone removes the config map from the Git and commits the change. If Prune is enabled, ArgoCD will automatically delete that config map from the Kubernetes cluster during the next synchronization. You can also see the same explanation by hovering over this question mark icon. It says if checked, ArgoCD will delete resources if they are no longer defined in Git. The third option is self-heal. This is one of the most powerful GitOps features. Suppose someone manually changes a Kubernetes resource directly in the cluster using kubectl edit or kubectl apply. Now the actual state of the cluster no longer matches the desired state stored in Git. This situation is called configuration drift. If self-heal is enabled, ArgoCD continuously detects this drift and automatically changes the source back to the exact configuration defined in Git. In simple words, Git always remains the single source of truth, and any manual changes made directly in the cluster are automatically reverted. Next, we have the set deletion finalizer checkbox. So what does this mean? In simple terms, if this option is enabled, ArgoCD adds a finalizer to the application resource. What this means is that when you delete the ArgoCD application, ArgoCD will first delete all the Kubernetes resources that it created, such as deployment, services, config maps, and so on, and only then it will delete the application itself. Well, this helps prevent orphaned resources from being left behind in the cluster. Since deleting resource can be a very destructive operation, you should use this option very carefully. Next, we have the sync options section. These options control how ArgoCD performs the synchronization. The first option is skip schema validation. If selected, ArgoCD skips Kubernetes schema validation before applying the manifest. This is mainly useful for special cases such as custom resource definitions, etc. The next option is auto create namespace. This is a very useful option. Suppose our Git repository says that all the application resources should be deployed in a specific namespace called SEH SIT. If that namespace doesn't exist in the Kubernetes cluster, ArgoCD will automatically create it before deploying the application. So we don't have to manually run the kubectl create namespace command. So let's enable this option. Next is apply out of sync only. If this is enabled, ArgoCD applies only the resources that are out of sync instead of reapplying every resource during each synchronization. Next we have respect ignore differences. This tells ArgoCD to honor any ignore differences rules that you have configured. So specified fields are ignored when comparing the live state with the desired state. Next is server-side apply. If this is enabled, ArgoCD uses Kubernetes server-side apply instead of the traditional client-side apply. This helps Kubernetes to manage field ownership more effectively, especially when multiple controllers update the same resource. Next is prune last. If this is enabled, ArgoCD performs resource pruning after all resources have been successfully synchronized, reducing the chance of deleting resources too early during a deployment. So below that we have prune propagation policy. This controls how Kubernetes deletes dependent resources when pruning. We have three options: foreground, background or fun. So foreground waits until all dependent resources are deleted before removing the parent resource. Background option deletes the parent resource immediately while Kubernetes removes the dependent resources in the background. And orphan, this deletes only the parent resource and leaves the dependent resources behind. Next we have the prune option. Here we have three values: true, false and confirm. True means automatically prune obsolete resources during synchronization. False means never prune resources automatically. Confirm means ask for manual confirmation before pruning resources. Similarly, we have delete options. Again, the available values are true, false and confirm. So true means allow deletion automatically. False means don't allow deletion. Confirm means require manual confirmation before deleting resources. Finally, we have two more options: replace and retry. So we will discuss these in details in later session when we cover advanced synchronization strategies. For now, we will leave all these options with their default values and continue creating our ArgoCD application. Now let's move to the source section. This is another very important section because here we are telling ArgoCD where our desired state is stored. The first field is repository URL, which is a mandatory field. Here we have different source types such as Git, Helm and OCI. Since our Kubernetes configuration manifests are stored in Git repository, we will select Git as the source type. Now from the repository URL dropdown, select the repository that we registered earlier. Since we have already connected to this repository to ArgoCD, it automatically appears in the dropdown. Next field is revision. Here we can choose whether ArgoCD should track a branch or tags. Let's first understand branches. A branch tells ArgoCD which branch it should continuously monitor for configuration changes. You will notice an option called head here. Head refers to the latest commit to the selected branch. By default, if no branch is explicitly specified, it points to the repository's default branch, which is typically main. This means whenever someone commits changes to the main branch, ArgoCD detects those changes. If the desired state stored in the Git is different from the current state running in the Kubernetes cluster, ArgoCD identifies that configuration drift and synchronizes the cluster back to the desired state defined in Git. Here in the revision, you can see we have main branch, also the another release branch as well. For now, I am selecting head only, which will track the latest commit on our default branch, which is main. The next field is path. This field tells ArgoCD where inside the Git repository it should look for the Kubernetes manifest to deploy. As we learned in the previous video, our repository follows a customized directory structure. Well, we have a base directory and a overlays directory. A base directory containing the common Kubernetes manifest like deployment.yaml, service.yaml and one customization.yaml. And overlays directory containing environment specific customization. Since we are deploying to the SIT environment, we will specify the path as overlays/SIT. Now let's understand what happens behind the scene when ArgoCD uses this path. Inside the overlays/SIT directory, we have customization.yaml file and a patch.yaml file. When ArgoCD sees a customization.yaml file, it automatically recognizes that this is a customized application. And here it reads the resources section. This tells ArgoCD to go 2 directories back and load everything from the base folder. So if I go 2 directories back, that is SA students config. Here if we open the base directory, we will find another customization.yaml file. That file contains resources as deployment.yaml and service.yaml. In other words, it's telling ArgoCD that these are the Kubernetes manifest that need to be deployed. Now before deploying, our SIT overlay customizes those base manifests. For example, we have configured namespace prefix SIT-. This means every Kubernetes resource created for the SIT environment will automatically have this prefix SIT-. So if the original deployment name is SH students-deployment, it will become SIT-SH students-deployment. Similarly, service name will also receive the same prefix. We have also configured this namespace. Namespace is SCH SITIN-ArgoCD UI, which tells ArgoCD to deploy all the resources into this specific namespace. Finally, we have this patch section. If we open patch.yaml, you will notice that we are not copying the entire deployment manifest. Instead, we are overriding only the fields that need to change for SIT environment. For example, here we are changing only replica count. So everything else is inherited from the base configuration. This is one of the biggest advantages of Kustomize. You write the common configuration only once in base, and then each environment such as SIT, UAT or prod contains only the differences. So for our application, we will simply provide the path as overlays/SIT. ArgoCD will automatically detect the customized application, build the manifest, apply the environment specific customizations, and deploy the final resources into our Kubernetes cluster. Now let's move to the destination section. As the name suggests, this section tells ArgoCD where the application should be deployed. In other words, which Kubernetes cluster and which namespace should receive these resources. The first field is cluster URL. Since we have installed ArgoCD inside the Kubernetes cluster and we are treating this cluster as our SIT environment, we will simply select the in-cluster Kubernetes API server. This tells ArgoCD to deploy the application into this Kubernetes cluster. The next field is namespace. This specifies the Kubernetes namespace where the application resource will be deployed. I will specify the namespace as SCH SITIN-ArgoCD UI. Here SCH represents the project name, SIT represents the SIT environment, IN represents the India region, and ArgoCD UI simply indicates that the application is being created through the ArgoCD UI. Also, you will notice I have already configured the same namespace in my Git repository inside the overlays SIT customization.yaml. That way, both the Git configuration and the ArgoCD application are pointing to the same namespace. Now we will leave all the remaining options with their default values and click on create. Perfect. Our ArgoCD application has now been created successfully. As you can see, the application SCH students is now visible in the ArgoCD dashboard. Let's quickly understand the status here. Healthy means all the deployed Kubernetes resources are running successfully and the application is in the expected state. Sync status synced. This means the live state of the Kubernetes cluster matches the desired state stored in the Git repository. We can see created at 2 minutes ago, last sync also 2 minutes ago. Perfect. Our first ArgoCD application is now successfully deployed and managed using the GitOps approach. Also, our application is now pointing to the Git repository that we configured. So if we click on this application, we can see all the Kubernetes resources that ArgoCD has deployed. Notice that every resource has now SIT-prefix, exactly as we configured in our Kustomize overlay. For example, we have SIT-SCH student service, SIT-SCH students deployment, then replica set, and 2 pods. Another thing to notice is that 2 pods are running. Remember, in our base deployment manifest, the replica count was 1. However, in our SIT overlay, we applied a patch that changed the replica count to 2. That's exactly what ArgoCD built and deployed into our cluster. Now let's validate everything from the Kubernetes cluster as well. First, let's check whether the namespace was created. For that, kubectl get namespace and the namespace name. We can see namespace got created. So here, this namespace was automatically created by ArgoCD because we enabled the auto create namespace option while creating the application. Now let's verify all the deployed resources in this namespace. Perfect. Everything looks good. Here we can see clearly 2 pods are running. One service has been created. The deployment is healthy with 2 desired, 2 current replicas and 2 available replicas. The replica set has also created and is managing those 2 pods. This confirms that ArgoCD successfully built our customized manifest and deployed them into the Kubernetes cluster. Let's also verify the service endpoints. More importantly, notice that the service has 2 endpoints. Each endpoint represents 1 running pod. This confirms that our service has correctly discovered both application pods and can now load balance traffic between them. Now let's access our application. Since the service type is cluster IP, it's accessible only from within the Kubernetes cluster. For this demo, we will use port forwarding. For that, let's run the kubectl port forward command. Now open the another terminal and execute curl command. Here this /API/v1 student/students is simply the REST API endpoint exposed by our Spring Boot application. So hit enter. If everything is working correctly, you should receive the student data as a JSON response. That confirms our microservice has been deployed successfully and is serving requests through the Kubernetes service. Perfect. So today we got a detailed understanding of how to create an ArgoCD application manually through the UI and deploy Kubernetes resources using a Kustomize-based folder structure following the GitOps approach. In the next lecture, we will learn how to create the same project and application declaratively using YAML manifest, which is the approach most organizations use to fully automate ArgoCD configuration. If you found this video helpful, don't forget to like, share and subscribe to the channel. Thanks for watching and as always, happy learning!